Engineering with Qualcomm Technologies to talk to us about some early learnings and use cases related to their work in 5G millimeter wave.
Well, thank you, Sean, and thanks for having me. So I have a few slides here for you guys today. And I will be, first, let me start by talking about 5G, where we are today on 5G. And this transition from 4G to 5G has really been incredible. We have now more than 100 operators with 5G commercially deployed, with another 305 operators investing in 5G in this coming year. The number of smartphones that we see is going to be about 3.8 billion. But look at the shipments that we're looking at in 2022, 750 million phones that will be shipped in 2022. If you remember, in 2020, we did about 245 million. 2021 is looking maybe approximately about 500 million. 2022 is going to be 750 million. So 5G really prevalent throughout the world that we're seeing in terms of where things are going. A number of connections. And really what strikes me the most is the number of designs that we are seeing from Qualcomm in terms of all the kind of design options for 5G. You know, it's not just smartphones, it's laptops, it's IoT, is fixed wireless, is automotive, you know, really in a wide variety of industries where we're seeing 5G being used. Let me get into some specifics into the deployments. In terms of NPV, and a lot of people ask me, it's like, hey, how do you compare mid-band and millimeter wave? You know, there's a lot of mid-band out there. There was a lot of interest in the C-band auction in North America. Things are happening. Of course, there's mid-band in China and in Europe. And there's a question now, okay, how does millimeter wave is positioned there? In the US, we already have plenty of millimeter wave. Now, the GSMA folks did a very interesting study where they look at the NPV, the total cost of ownership, whether you had 3.5 only, or if you had 3.5 and millimeter wave. And the results were really in line to what we expected. When you have certain amount of density, your cost is going to come lower because now you're able to offload all that traffic into the millimeter wave bands. So if you see on the chart, when you have about 5% of connected users and you have a semi-dense network like China, your NPV starts coming down. Of course, the denser the area, like in the case if you had 25% of connected users, the numbers start looking very significant. Like in the case of China, it comes down to 72% compared to if you only had 3.5, and in the case of Europe as well, 65%. Now let me get into the early experiences and what's going on in the different types of lessons learned that we have on different types of deployments that we're seeing. I will start with what we're seeing on indoor enterprises, then I'll focus I'll talk about venues, transportation hubs, FWA, and then IoT. On indoor enterprises, this is your typical carpeted enterprise where we're seeing, we wanted to really verify that millimeter wave was working well. It's really a lot of questions around the propagation, and we've done a lot of tests around this. And what we find is that in indoor enterprises, you can pretty much replace one-to-one a millimeter wave access point with a Wi-Fi access point in terms of coverage, in terms of where, you know, it's easier because a lot of these access points right now for 5G millimeter wave, they don't require high power. You can actually power them with PoE. So it's very easy to actually replace your Wi-Fi box with another box that may have Wi-Fi and millimeter wave. So very encouraging results. And in terms of propagation, this is actually a map of one of our buildings at Qualcomm where we did a test. You're getting very strong coverage. It's the greenish area, very strong coverage, both in the front part of the antenna and the back end of the antenna. because of all the reflections actually around the building. So, and you can even see some of the hallways, propagation there. So we have another test where we actually did the whole floor, and with very good results. Of course, this is a parallel network to Wi-Fi, where you would have 5G, exclusively 5G, and then you have, of course, multi-gigabit per second kind of speeds, different latencies, different kinds of security. So it would be a parallel network. So we're very excited about this kind of application in indoor enterprises. The next area is venues. Venues is getting a lot of attention. We actually were involved in the last Super Bowl that was played a few weeks ago in Tampa, and in there, one of the main carrier actually did a lot of effort in putting tons of millimeter wave sites, 79 millimeter wave sectors, and that it's a low number compared to the amount we used to have to do in 4G, where you have to sectorize a lot more. So with this, the experience that we were able to obtain at the Super Bowl was, in fact, 18 times more. These are the different levels in the bowl. So across the bowl, you can pretty much cover a whole stadium with very few nodes, much fewer for the experience than you would need for a 4G. So millimeter wave in venues, stadiums, convention centers. There was recently, actually yesterday, Mobile World Congress Shanghai opened up, and even in China, they're showcasing tons of millimeter wave there. So every, several booths had millimeter wave, really in preparation for the Winter Olympics 2022. So we're seeing really a lot of use on venues and airports for millimeter wave. Really good experience. Of course, you want millimeter wave when there's people, where you do have the demand. A very common one that we see is a transportation hub. So we went ahead and, in terms of early experiences, we've seen a railway station where there were two nodes, with just two nodes in the railway station, where there's a lot of demand. People were waiting for the train to come by in the tarmac. First thing people do is pull up their phones. They want to use the web. So tons of traffic demand there, where you can actually absorb it with millimeter wave. And in that case, we have, again, very, very good speeds, no issues in terms of coverage, multi-gigabit per second, and very decent uplink speeds as well. Let me go into another use case that we're also seeing for millimeter wave. This one has to do with fixed wireless. Qualcomm has this fixed wireless CPE that is actually, it's called a high power CPE, and it actually has a higher gain antenna. So it's a product that has a module that is specifically for fixed wireless. That allows you to extend the coverage of millimeter wave. And we did several tests, one in the US, one in Australia. This particular one is in Europe, in Italy. And we were able to get up to 6.5 kilometers to closing the link at more than 1 gigabit per second. So this is on your, if you have already a deployment and you install millimeter wave, you can reuse your deployment for millimeter wave for fixed wireless. So you can use it both for mobility and to provide customers for fixed wireless. In fact, we have several operators in Latin America where this has actually made their business case much better, because they were only assuming that you would only get 100 or 200 meters with millimeter wave. But when we came up with the high power CPE and says, well, you can have line of sight, you can put high power CPEs, and then you can actually have very large distances. So the economics around this become much, much different. Let me go into another use case, and this is a smart factory that we did in Taiwan. And in this case, they had a manufacturing floor. It was 35,000 square feet, 12-foot ceiling high. And what they wanted to do here is kind of like a SMT line. And what they wanted to do is really have a rover, an AGV, actually go around each one of the aisles and verify the production quality, inspecting anything that might be abnormal. And it's all high quality video feed, all around the plant. And of course, it's guided, so have certain routes. In order to do that, we went ahead and deployed this millimeter wave network, this private network. And it was shown a couple months ago. And so they have not only the AGV, but also you want inspection in terms of AR for troubleshooting, maintenance, repairs, looking at boards and seeing if there's anything wrong with boards. So for that, we ended up with this site. And if you can see, red is bad, and this is a path loss map. Red is bad, green is good. You really don't see almost any reds. So pretty much, and again, the capacity that we deployed here is they want to do a lot more things in the future, such as precise positioning, which I'm pretty excited about. And for that, sometimes you need you need to be able to get line of sight out of multiple GNODs. So in that case, there were a few more nodes that we needed, but it's very, very, very interesting project in a manufacturing floor. So let me tell you what's next. So far, 5G has been release 15. So all these things that we're seeing right now that are commercially deployed are release 15. What's coming up is release 16, and it comes with a lot of very interesting things. One of them is, for example, integrated access and backhaul. I mentioned the one where you have to do fixed wireless access. Well, you may not have backhaul in all these points where you want to install a GNOD. So this allows you to take the bandwidth and split it between how much you want for access and how much you can actually dedicate for backhaul. So you don't really have to have a fiber link to every one of the GNODs. So you actually, it's called integrated access and backhaul, a very efficient way to use the same spectrum for both access and your backhaul to the next node. So you can actually start linking some nodes. There are more features coming up, such as enhanced beam management. With this one, coverage and robustness is always important. So there's a lot of new algorithms for enhanced beam management. Power savings features, obviously power draw on millimeter wave, we can always do better. So there's a lot of very interesting features that are coming up. It's not just millimeter wave, but overall for all the 5G bands, where on the device you have more efficient sleep times and you can wake up faster, and you can do a lot more things that saves the battery life. The other piece on release 16 is dual connectivity optimization. So really this is more about reducing latency. If you recall, in release 16, for industrial IoT, we start having what it's called enhanced URLLC that gives you a very, very reliable link. It's actually 6 nines is 99.9999%, a very reliable link. And that actually it's coming up in release 16. And then finally, positioning. This one, I believe, is going to open up a whole bunch of possibilities in terms of warehousing and industrial and guiding. Having the ability to do positioning indoors is very critical. Indoors or outdoors, outdoors for ports, airports. There's a whole bunch of industrial areas where precise positioning, especially in cases where GPS might not be available, like in indoors. This is a very, very powerful thing to have. And indoors, you could actually get to 20 centimeters. So very interesting development coming up, actually in release 17. So a lot more things coming up. We're just getting started on this 5G road. And of course, it's not enough to just talk about what's coming up. It's good to actually have products to show as well. So I think a couple of weeks ago, we just announced our latest modem. It's our 4th generation modem. It's called SDS 65. And it's the first time that we actually breached the 10 gigabit barrier. So it's really a beast. It actually is able to aggregate work millimeter wave, FDD, TDD, and all kind of combinations of bands. It's not just a modem, of course. You need the whole platform with the whole platform is available with both millimeter wave and sub-6, and it's also the first chip that supports release 16. So we're very happy that we have that product announcement, and they will support all these things that I just talked about. And finally, there is also, it's good to be in this program. There's a very interesting paper that was written by 5G Americas, and I invite you to take a look at it. And it talks a little bit more about millimeter wave spectrum and some of the other additional business cases. So very, very good paper. So with that, I will open for questions.
Unfortunately, Alex, we've run up against our time, but we appreciate that presentation and that look at what's coming down the line in terms of millimeter wave networks. So thank you so much for sharing your perspective and the work that Qualcomm's doing. And now for the audience, we're going to roll into a session with Chris Pearson of 5G Americas. So thank you, Alex.
No problem. Thank you very much.